We'll proceed in vector summation integral. Okay, so we will proceed in vector summation integral. Concept is dividing problem into n different parts. Solve part by part and do the summation. If summation is not accurate, then make n tends to infinity. If someone is doing summation I equal to 1 to n and each part summation where n tends to infinity, then it is not possible by the summation. In that fashion, someone has to migrate the summation into integral calculus. That we have seen already how to migrate summation into integral calculus. Okay, more or less, not very perfectly, but more or less. How to come to summation, divide the problem into n parts, solve each part, and then add it. This is called summation. While adding it, if n tends to infinity, then the summation has to be transferred to the integral calculus because integral calculus has inherent characteristics to do the infinite addition of sub area. That is the problem with the integration. Integration cannot do infinite addition of items. Integration can do infinite addition of sub area. If someone has a height and a width, this is one area. If someone needs to add all the contiguous non-overlapping area, add, then this is integral calculus. Summation means summation of one item. Summation of one item. This item can be broken into height into width. That is different thing. But summation is summation of so many items. That's it. It may not be sub 8, it may be sub area whatsoever. It is up to the person. That is a summation. Now we have waged a war that how to do how we I can break things into n different items, but each part how I can solve through vector. That is the concept that we are pursuing. How each part can be broken into vector. Okay, so in that form we will see kind of again a calculation of the area. If I want to calculate the area, if I want to calculate the area, this is circle and I'm trying to calculate the area of the circle. This circle can be in two parts. There are two kind of circles that we have discussed. There are two kind of circle that we have discussed. One circle is centered at the origin. This is x-axis, this is y-axis. This is a circle where a radius starts from the center and it moves like this and makes a 2 pi angle, 360-degree angle, where radius is constant and angle is moving. Okay, in this fashion we have, this is also called hybrid model of Cartesian coordinate system and polar coordinate system. This is xy axis, this is Cartesian coordinate system. If this radius is moving like this, then this is radius and this is angle. This is polar coordinate system. This is superimposing Cartesian coordinate system and polar coordinate system together. Okay, now what is separated? If someone is saying Cartesian coordinate system and polar coordinate system, if I mix it together, then Cartesian coordinate system will be like this: x-axis, y-axis. This is origin. Whereas polar coordinate system will be a radius that will go like this in angular fashion. This is angle, and this is the radius. That is the polar coordinate system. I was going through two kind of circles. This is one circle where radius is constant and theta is changing. There is another kind of circle where the origin of circle is not at the center. Origin of circle is rather it is at the bottom of the circle. This is origin of the circle. Okay, this is origin of the circle. This is origin, and this is x-axis, and this is y-axis. Circle is going like this. Okay, this is going like this. In this fashion, this is x-axis and this is y-axis. Radius is like this. Radius starts from 0. Radius starts from 0 and radius starts growing as theta is growing. When theta is 90 degree, radius is maximum. When theta is beyond 90 degree, then radius is decreasing. When theta is 180 degree, radius comes to 0. This is also a circle. If this is a circle, then angle is going 0 to pi only, 180 degree to form a full circle. 360 degree is not required. Only 180 degree movement of the angle make the circle, where radius is r equal to sine theta. When theta is 0, radius is 0. When theta is 90 degree, radius is full. When theta is 180 degree, then radius is 0. There can be another circle like this, where the center is here, and this is the circle. Equation of this circle is r equal to cos theta. So r equal to cos theta, r equal to sine theta. The center of the circle is other side, not at the middle here. Or center of the circle depends upon the equation. Center of the circle is here, here. This is r equal to sine theta, and this is r equal to cos theta. R equal to cos theta. R equal to cos theta. Okay. Now what we are going to talk, it is not available in any of the book. Beyond of some time, then it is not available. Anyway, now someone would say, can you divide this xy plane and r theta plane separately? Because what you are showing as a circle, primarily it looks like in xy plane. Okay, yeah, it looks like in xy plane. Forcibly, we are showing radius is moving like this, but actually it is xy plane. Can you show two different plane? Yeah, I can show two different plane. Consider this is r theta plane. This is theta axis and this is r axis. This is theta r plane, pure theta r plane. And this is xy plane. There are two planes. This is r theta plane and this is xy plane. This is x axis, y axis. This is theta axis and this is r axis. Here also they are perpendicular to each other only. Because theta r is a coordinate system called polar coordinate system. Polar coordinate system, theta and r are perpendicular to each other the way x, y are. These are high-end explanation in the coordinate system. This is theta and this is r. Consider theta is growing like this, but r is parallel line, means r is not changing. Can someone consider hook? Where is the other line? Okay, as theta is growing, r is a flat line. R is a flat line. R is a flat line. Means if theta is growing, consider r is a, and theta is going from 0 to 2 pi. If I draw a line, it is a straight line, flat line. Means when theta is varying, this radius is not varying. It is always a. It forms a rectangle. Makes sense? If this is theta r plane, then if radius that is perpendicular, it is not changing with the theta, it forms a rectangle. Okay, there is a xy plane here. Now, if I take any point here x comma y, then x equal to r cos theta and y equal to r sin theta. They are related to each other. This is xy plane. This is theta r plane. In theta r plane, I have a rectangle. Rectangle means r is not changing with the theta. R is constant. Okay. If I say this is time and this is velocity, then person is walking with constant velocity, constant speed. If this is time and this is distance, then distance is constant. Means he is not walking at all. He is standing there only. That is called distance is constant. If person is walking with the constant velocity, then velocity is constant. This is velocity axis. If person is walking with constant acceleration, then this is time axis, this is acceleration axis, and this is acceleration is constant. If acceleration is constant, then velocity is like this. If it is velocity in time, then velocity is like velocity is growing. If that is the case, then distance will go like this. Okay, x square or something like that. Means distance is changing like exponential. Then velocity will go like a flat line. Then acceleration will be like this. If distance is like this, then velocity will be 0. Anyway, now I believe it is understandable now. So I have a constant radius. Radius is not changing. Everywhere it is a only, but theta is changing 0 to 2 pi. If there is a rectangle in theta or plane, then what shape I can expect in xy plane when they are related like x equal to r cos theta and y equal to r sin theta. Rather, I would say x equal to a cos theta because radius is never changing. Y equal to a sin theta. If I take x axis, then x equal to a cos theta, y equal to a sin theta, x square plus y square equal to a square. Means there will be a circle like this centered at the origin. In theta r plane, up, where one more one. Okay, in theta r plane, if there is a rectangle, it's not there. In theta r plane, if there this is theta and this is r, this is a rectangle, and this much and this much. This is a rectangle. This is 2 pi and this is 0. This height is a. If there is a rectangle in theta r plane, then if I go in xy plane where x any point x is a cos theta, r cos theta, and y is r sin theta, it will form a circle because x equal to r cos theta and y equal to r sin theta, x square plus y square equal to a square. So it will be a circle. Hope makes sense. Concept is how I can find area of a circle in xy plane. That is the concept. That's it. X square plus y square equal to a square is equation of a curved line. How to find area? For that we are going for these many fundamentals. There are two fundamental. One fundamental that we brought in theta r plane. That is one fundamental. Another fundamental that we have to break into n parts because our discussion is vector summation and integral. We have to divide problem into n different parts and then solve part by part. That is the concept that we are pursuing. Okay. In that fashion, if I now the equation is circle. Okay. Now this is theta r plane. In theta r plane, hope. In theta r plane, I have a rectangle. In theta r plane, I have a rectangle like this. Okay. So in theta r plane, I have a rectangle like this. Consider this is a rectangle. I have a rectangle like this in theta r plane, where this right hand side is 2 pi and height is everywhere it is a. Now chop this theta from 0 to 2 pi, chop into n part and 0 to a chop into m part. There will be m into n area will get formed. Now we have come to our business. Okay, if I see like this, then I have divided this into m part, n part, theta axis into n part, and then r axis 0 to a into m part, m for monkey. Then I have a mesh of rectangle. Each rectangle has a width of delta theta and height as delta r, where delta theta is 2 pi by n and delta r is a by m. If I calculate the area of this, if I calculate, I'm sorry. Now, okay, let's move on. What we want, if this is the rectangle, accordingly, if this is theta r, in xy plane, we have circle here. We want area of the circle, but we are cutting. This is not available in any of the book. Anyone can try. Now we are cutting down a rectangle. If this is a circle, I make another equation x equal to r cos theta, y equal to r sin theta. If I have such a relationship, then circle in xy plane, it will go and map it in theta r plane as a rectangle, where I am chopping the theta axis into n part from 0 to 2 pi and 0 to a I am chopping into m part. If I take a small one section, ith 0 to 2 pi, first part, second part, ith part. 0 to a, m part, first part, second part, jth part. If I take ith and jth part, it will be a rectangle where width is delta theta I and height is delta rj. There will be a small rectangle here, delta theta I, delta rj. If I move along delta theta, then r is constant. If I move along r, delta r, then theta is constant. Okay. Now I have any point here. Now consider there is a small section and that is the ith section of theta and jth section of r. Bottom left corner is theta comma r. Consider like that. It is theta comma r. Okay. Then if I go in xy plane, that will map to some point x comma y because of the relationship. If I take any point theta comma r in theta r plane, it will go in the xy plane and it will map at any point x comma y, where x is r cos theta and y is r sin theta. If I move delta theta, keeping r constant, if I move delta theta keeping r constant, in that fashion x equal to r cos theta, x equal to r cos theta. If x is a point here, now watch very closely now. Okay, consider that this is a circle here and this is x-axis, this is y-axis. This is center. Okay, this is a circle. Now I am at any point x comma y. Consider this is the radius line. This is x-axis, radius is here. I am at any point x comma y. If this is x comma y, then it has made an angle with x-axis theta and radius is r. Makes sense? This is x comma y. Now matching to this on theta r plane, there is point called theta and r. Theta r is a point on the ith jth section break bottom left corner point called theta and r. Makes sense? If this is theta r plane, I have chopped into n part, I have chopped into m part, a and 2 pi. I'm talking about ith jth section. The bottom left of the ith jth section is theta from the zero origin, and bottom left section from the origin it is r distance right now. That r will go 0 to a and theta will go 0 to 2 pi. Now that theta r, if I talk in xy plane, then xy plane, okay, then it will be any point here. If this is x-axis, then it will be any point like this. And if I talk about this point correspond to x, this point is x comma y, then this point corresponds, this is this point, may not be at the perimeter because radius is not a, somewhere here, and angle is theta, somewhere here, middle. Now if I talk this point here, then this is making theta degree with the angle because there also we are at theta from the origin, and from origin it is at r distance. Full distance is a, full angle is 2 pi. Now this is r comma theta. If I move along theta, there from theta I move delta theta, keeping r constant. Keeping r constant from theta to delta theta I move. Makes sense? This is $1 trillion explanation we are giving. This is not available in any of the book. Okay, if this is x-axis, consider this is the another line. This point is x comma y. This point corresponds to r theta out there. This means the distance from origin to this point is r. Means if this is x and this is y, then this is x square plus y square equal to r square. Makes sense? This angle is theta. Means tan inverse theta is y by x. Because that is the relationship, x equal to r cos theta, y equal to r sin theta. Tan theta equal to y by x, theta equal to tan inverse y by x. X square plus y square to r square. If this is r, then this angle is theta corresponding to r theta there. If I move in theta, I move the theta delta theta, r is constant. This is how I am moving in the ith jth section. Theta to theta plus delta theta, keeping r constant, and theta comma r to theta comma r plus delta r, keeping theta constant. Make sense? Now there is a one line that will go like this. This is arc line. Where arc line, the angle of movement is delta theta I, r is constant. Now keep theta constant and move in r plus delta r. Now I have one area strip like this. Makes sense? This is r, then r plus delta r keeping theta constant. If this is r and this is theta, then theta moved delta theta. Theta moved delta theta, keeping r constant. I have an area strip like this. One arc which is from origin r plus delta r. Another arc from origin it is r. And angle of the swapping is delta theta I. This is one area I get. This area, circular area, something like if this is one line, then another line is parallel to this, and this is radius. One chop, another chop. This section, but this is not at the perimeter. Somewhere in the middle, I'm getting like this. This is the area that corresponds to a rectangular area in the r theta plane. These are priceless things. No one will talk like this. Okay. Now we have in the r theta plane, I have ith jth section. I have chopped into n part, m part. Ith jth section. Okay. If I have something in ith jth section, in the theta r, that is a small rectangle, delta theta into delta r, that is the area of the rectangle. Okay, where it starts from theta comma r, move theta plus delta theta. Okay, where r is constant. So there are 3 points. One point is theta comma r, another point is theta plus delta theta comma r, and another point is theta comma r plus delta r. That rectangle would move like a arc slice here in the xy plane. Okay, now what is the area of this circle now? What is area of the circle? Area of the circle is related to all the, if for one rectangle, one sub-rectangle, we have area like this. If I add all the sub-rectangle in that fashion from 0 to a and theta to 0 pi, it will make so many n into m sub-circular region. Sub-circular region. If I add all, I get the area of the circle. Means if I add all the rectangle there, if I do the computation where all the rectangle in theta are plane mapping area here will get added, then I get the concept. Okay, now it is summation I equal to 1 to n, summation j equal to 1 to m. Okay, area, okay, I would say mapped area. If I have I equal to 1 to n and j equal to 1 to m in the theta r plane, then that summation and area mapped into, so I would say the area formed with the mapping, so I can say function over area in theta r plane. Theta r plane has a rectangular area. If I map this on, or mapped area on the xy plane, if I add all the mapped area, I get the circular area that we are thinking of. Okay, what is the mapped area? Now, anyone would, I would rewrite it. Summation I equal to 1 to n. Summation j equal to 1 to m. Sigma is summation sign. Sigma I equal to 1 to n. Sigma I j equal to 1 to m. Mapped area, someone can say map, M-A-P, map, and in bracket, area of the ISJS section, whatever the area of the ISJS section here in theta r plane, if I map it to xy plane, whatever the mapped area, that mapped area is the area of the ISJS section. If I add for all the area in circular, I get the area. What is the area? What is the, now question is arising, thank you very much. You found one way, but what is the area of the mapped section? That is their area, I know. Their delta theta I into delta rj is the area. But what is the area here? Okay, now here there are, if I watch it, consider if there is a theta r, then there is a x comma y. If there is a theta r, there is a x comma y. Okay, if that is the case, then if I move theta plus delta theta comma r, where r is constant, okay, theta, then I move to another point. Next, if there is one point x comma y belonging to theta comma r, if theta is changing, r is constant, then it is going to different points there in theta r plane, and that is theta plus delta theta I comma r. Similarly, from x comma y, I will go to another point anyway. What is the point? People understand. Okay, that is the point in the angular fashion. It will go, if this is the first point x comma y corresponding to theta comma r, it will move in angle, and this is another point, that is theta plus delta theta I comma r corresponding to here. This is theta comma r, this is theta plus delta theta I comma r in xy plane. Okay, if I get the vector of this, if I get the vector of this, then there is another line, that is from theta comma r to theta comma r plus delta r. If this is x comma y, I will have to move along radius direction keeping theta constant. That point corresponds to theta comma r plus delta r. Now I have 3 points here also. One point is theta comma r in xy plane. If I talk about xy plane corresponding to theta comma r, I have a mapped point here. What is mapped point? Consider x equal to g theta r. X is a function over theta and r, and function name is g. X equal to g, and in bracket theta comma r. Y equal to h theta comma r. Then the point corresponding to theta comma r here is g theta r comma s theta r. There is a point g theta comma r s theta comma r. There is another point that moved in angle keeping radius constant. That point is g theta plus delta theta I comma r s theta plus delta theta I comma r. This is one point. If I represent this line as a vector, this will be one vector. If I say this point is P, x comma y or theta comma y, this point is P1. I have P1 vector. Okay. Now I have to have one P2 vector, where from theta comma r or g theta comma r comma s theta comma r or x comma y, I'll move along radius where theta is constant. Okay. Now I'll move along radius where theta is constant. First I move along theta where radius was constant. So this is the arc. So this is the vector. Another is a straight line vector, that where theta is constant, I have to move. In this point is P g comma theta comma g theta comma r comma s theta comma r x comma y. Then another point is g theta comma r plus delta r j comma h theta comma r plus delta r j. If I find these two vectors, if I do cross product, I'll get the area. Whereas what is area on that side? That is delta theta I into delta rj. Delta theta I into delta rj is the area. But that area, if I try to get in the mapped area in xy plane, I cannot multiply directly because it is a curved area. It is not a straight line area. That is the problem. So if I have a curved line area, then I have to go with the vector representation of two lines, and you do the cross product of it. One is P1 where theta is varying and r is constant. One is P2 where r is varying and theta is constant. Okay, what is P1 vector and what is P2 vector? That we have to find. If I say dp by d theta, then if I say dp by d theta, then P is a position vector in xy plane. If this is xy plane, this is a circle. There are two ways to find it. Okay, the vector I'm trying to, if I say P1, there are 3 points. One point is x comma y corresponding to theta comma r. One point is that point is P. Another point is P1. That is new x comma y that corresponds to theta plus delta theta comma r. And there is a point called P2, and P2 corresponds to theta comma r plus delta r. Okay, that is the point. Now I have P1 vector where theta is changing, r is constant. I have P2 vector where r is changing and theta is constant. Now if I get P2 vector and P1 vector, if I do cross product and that its magnitude, I get the area. Then I have to sum it for all I and j. That is the concept that we are talking about. Okay, then what to do here? There are two ways. First, you get the P1 vector and P2 vector and do the cross product. There is another analogy of it. Consider I have a point P. Point P is a position vector. Oh, what is position vector? This is x-axis, this is y-axis. If this is x-axis, y-axis, I'm talking about any point here. This is origin, and this is the end of the circle. This is the circumference. I have taken any point r here, distance r. Okay, if I move angle theta, then this is delta theta. Or from r I move delta r. Okay, so if I move delta r, this is point P, then this is point P2. If I move in angle keeping r constant, then this is P1, P1, P2. Okay, now if this is P, then it has a position vector, and position vector is xi plus yj, where x equal to g theta r, function over theta r, and y equal to h theta r, function over theta r. If this is position vector, and I have this side, so this is called driving side. Theta r plane is a driving side because I have chopped into n part into theta r plane. There I have not done anything. Now I have similarly I have point P, P1, P2 there also. P is theta comma r, P1 is theta plus delta theta I comma r, and P2 is theta comma r plus delta rj. Okay. Now here, if I say if this is a point P in the xy plane, then what is dp by d theta? dp by d theta means there is a point called theta comma r. If I move 1 unit along theta, keeping r constant, if I move 1 unit, what is 1 unit? 1 unit is negligible. 1 unit means 1 picometer, 1 nanometer, 1 unit. It is not 1 meter or 1 centimeter. If I say theta is 0 to 2 pi, then that is not 1 unit. Any 1 unit, if I move along theta keeping r constant, then how much position vector would move? Okay, if this is the radius, if this is the radius, if this is the radius 0 to r, okay, this is position vector p. Now if I move in theta keeping r vector, then it will move like this in radial fashion. Angle move, radius is constant, so it will move in a curve area manner. Okay, if I move in theta, this point will move like a circle. Okay, how much this, what will be a new point? If I move theta, if I move delta theta, this point is going from here to here. If I move 1 unit, just 1 unit, that is negligible, 10 to 0. If I move 1 unit, then how much position vector will move? That is dp by d theta as per the calculus. dp by d theta means at any point P, if you make 1 unit change along theta, then how much position vector will change? This is dp by d theta as per the calculus. As per the first principle of the differentiation, dp by d theta means 1 unit change in theta at any moment. I can say dp by d theta at theta equal to theta 1, means at any point theta 1, at any point theta 1, if I move 1 unit, how much position vector will change? Position vector will change means if this is the point P and this is angle theta with this, if I make 1 unit of change in angle, then position vector went here. Okay, how much change in position? Change in position vector means if this is P and this is P alpha, if this is P, consider this is P3. This is P, this is P3. What is P1 minus P3? Then this is this vector, subtraction vector. How much position vector change? How much position change? Position change from P to P3. What is delta P? Change in the position vector. Change in position is first point in x comma y. It went to x1 comma y1 when there is 1 unit of angle change. If I connect x comma y to x1 comma y1, it will tell you dp, change in the position vector. That is the line connecting P and P3. How much we see change in position vector when there is 1 unit change of angle theta in the theta r plane at point theta comma r, that is dp by d theta. If it is dp by d theta, makes sense, then this is called position vector. This is the position vector change along theta when r is constant. This is dp change in position vector. That is a vector that will connect P and P3. Okay, how much position vector is changing when there is 1 unit change along the radius in theta r plane when theta is constant? From P, how much P would move along the radius when theta is constant? When radius movement is 1 unit, dp by dr. So dp by dr and dp by d theta, if I do cross product, it will give the small section area when there is 1 unit of change along theta and 1 unit of change along r. dp by d theta cross dp by dr. Okay, that can be written as dp by d theta r. Means if there is 1 unit of area change in theta and r, how many, if I say dp by d theta, then how much position vector is changing if 1 unit of theta is changing? Okay, consider this is the case. Then what we want? What is our net area here? That is summation I equal to 1 to m, summation j equal to 1 to m, mapped section from the rectangular region in theta r plane where width is delta theta delta r, mapped section in xy plane for the area of the ith section in theta r plane. This is what I want. We are trying to find the area of ith section in theta r plane. What is the mapped area in the xy plane where the we have chopped into n part and m part. Now, if I move 1 unit in theta keeping r constant, then vector is moving dp by d theta. If I move 1 unit in r keeping theta constant, one is keeping r constant, then it is dp by dr. Now, dp by d theta is the movement in position vector in xy plane when there is 1 unit of change in theta r plane. Okay, if 1 unit of theta change brings dp by d theta movement in xy plane, then how much it will move when there is delta theta I change? dp by d theta into delta theta I. Okay, cross product with dp by dr into delta rj. That is the area of the ith section. That is dp by d theta into delta theta I cross dp by dr into delta rj. That will be dp by d theta cross dp by dr outside delta theta I delta rj. I believe it makes sense. This is the area of the mapped section here where there is a rectangular region in theta r plane which width is delta theta I and r is delta rj. Okay, now we have summation I equal to 1 to n, j equal to 1 to m, d theta dr, dp by d theta where p is position vector in xy plane. dp by d theta means how much position vector is changing if theta is varying r constant. Cross product dp by dr, how much position vector is changing when theta is constant along the r. Cross product into delta theta I delta rj. This is the net area of the circle. Now dp by d theta cross dp by dr, whatever it comes, it will come as a vector. If I calculate magnitude of it, then map the section in xy plane, I'll get its area. So now it is magnitude of dp by d theta cross dp by dr into delta theta I delta rj. This will come dp by d theta. dp by d theta will come in a function of theta and r. dp by dr will come in a function of theta and r. More or less, I have function over theta and r when theta is at ith section and r is at jth section into delta theta I delta rj. Please watch our previous video. This is a fit case where I is from 1 to n and j is from 1 to m. N tends to infinity and m tends to infinity. Why we are making it infinity? We are making it infinity because if I talk about this circular region, this region in xy plane, then if I talk about position dp by d theta, if I say dp by d theta, dp, if I say dp by d theta, then this position vector is moving like this, keeping r constant. But position by this is p and this is p3. If I connect, this is a straight line. dp by d theta is there when 1 unit of change is there, but position vector will go from one point to another point. If I connect this vector dp, that will be a straight line, but we want arc line. In order to have the arc line and straight line behave the same, I need to have the chopping we are making n chopping that tends to zero infinity. Means each if this is moving delta theta I, this angle, whatever the angle we are talking, this angle should be infinitesimally small so that this movement, what vector we get, that vector delta p vector will be like a curved line. It will be same. If I am moving this angle, if I am moving this angle like this, then this is a curved line. Curved line and a straight line should say, okay, but this is not a very big functionality here. We will talk about it. Why you are making n tends to infinity is we brought in calculus. This is a better explanation. Leave that fundamental. That they will be tends to 0 and leave that fundamental. Right. Why we are bringing like this? Because we entered into calculus. dp by d theta means calculus means n should be tends to infinity. If I am bisecting something into n part and we are entering into calculus, n must be tends to infinity, then only calculus will work. Now we have summation I equal to 1 to n, n tends to infinity. Summation j equal to 1 to m, m tends to infinity. dp by d theta cross dp by dr magnitude delta theta I delta rj. This is as good as a function over theta and r, where theta is in ith section, r is in jth section. Delta theta I delta rj. This is a or delta theta r. This is a fit case to convert into integral calculus. That is integral of theta r in theta r plane. Integral over theta r plane. What is theta r plane? Theta r plane is a rectangle. Integral over a rectangular region in theta r plane. Watch it. This is very precious. Integral, if this is the in theta r plane, it is a rectangle. In theta r plane, we have a rectangle where height is constant a, and in xy plane there is a circle. Okay, now I have to integrate this function over theta r and d theta r. Then it will be integrated over the complete rectangular region in theta r plane, because we have chopped into n part theta and r we have chopped into m part. This is actually a rectangular section. Rectangle. Rectangle is dimension of the rectangle is one side is 0 to a, another side is 0 to 2 pi. I have chopped into m into n part where m tends to infinity, n tends to infinity. If I do integral means I have to take care of the full area. All the section I have to add in summation. Means integral will take care of this area. This area, since both are independent to each other, now I can write as theta 0 to 2 pi and r is 0 to a. Function over theta r, d theta r or d theta dr. What is function over theta and r? That is d theta by dr, dp by d theta cross dp by dr. What is p? P is position vector in xy plane. That is xi plus yj. D of xi plus yj by d theta cross d of xi plus yj by dr. This is the basis of calculating Jacobian also. Okay, now in this method, what is x? R cos theta. What is y? R sin theta. D of r cos theta I plus r sin theta j by d theta. Keeping r constant. Cross, this is how it is. D of r cos theta I plus r sin theta j by dr. Keeping theta constant. Because the way we move. First, someone calculate do cross product of another. It will come in a Jacobian, that is r. d theta. Theta is 0 to 2 pi. R is 0 to a. R square by 2. A square by 2. 2 pi. Pi a square is the circle of the area of the circle. We will proceed of this. It is not that straightforward the value. What about the circle is r equal to sine theta. Right now we have taken radius as constant and theta is varying 0 to 2 pi. That is a rectangle in theta r plane. Consider r equal to cos theta and r equal to sine theta. What it will be through the vector. Concept is use vector to find the one subsection in the nth part. Sum it in the n to n part, make it infinity and bring into integral calculus. This is not available in any of the anyone can take. Please don't mind supporting us. +91 is the India country code 9483160610. Please mind supporting us. +91 is the India country code 9483160610 is the telephone number.